be talking about nomenclature today, and specifically the names and formulas of polyatomic compounds. This is about lesson 3 in our nomenclature series, and it's just going to talk, we're taking our understanding of ionic compound naming a little bit further. Okay, so on the side here, you have an example of what's called a polyatomic ion. So a polyatomic ion is the term that's given to a group of atoms that act as a single atom. And what's meant by that is simply that these are atoms that are really strongly attracted to one another, and so they kind of stick together and move as a group. Okay, so the essential idea here is that polyatomic ions always remain as a group. So even though there are kind of a few different types of atoms present in a polyatomic ion, they still will all move together and function for most intents and purposes as a single ion. So you have some examples of different polyatomic ions here, and I've provided you with a visual of what these polyatomic ions look like. They are essentially molecules that sort of stay together, and so you can see that there's, in a nitrate ion, there are actually there's one atom of nitrogen and 3 atoms of oxygen. Okay, each polyatomic ion has its own charge, and the charge is indicated on this table. So for example, NO3 has a charge of 1 minus. Okay, if you take a quick look at the table, you'll notice that the ammonium ion is the only one that's actually a cation. So that means that it's the only one that's positively charged. All the rest are anions, therefore they're all negatively charged. So if we think about the context of ionic nomenclature, then you can have a polyatomic ion as your anion in an ionic compound. How do you write the formula for polyatomic ions? So they're written the same way as other ionic compounds, but you have to be careful. Okay, and you just got to be careful to make sure that you know whether or not you're dealing with a polyatomic ion or if you're dealing with just a simple anion. So, for example, we have, if we look at the table again, you have something like nitrate, which is a polyatomic ion and includes oxygen atoms, whereas nitride is simply nitrogen. So you just have to be careful. So you want to make sure that you're checking the ending of your nonmetal. Especially. If it ends in "ide," that means that it is not a polyatomic ion. It would necessarily be just an element, essentially just an anion on its own. The exception is with hydroxide. Hydroxide is OH, and that is, in fact, polyatomic. And the other thing that you need to remember about polyatomic ions is that you never reduce the subscript in a polyatomic ion. So as we covered in our first lesson on Lewis diagrams, and also in our lesson on just ionic naming, whenever you get an ion that has, whenever you end up with, a compound that has subscripts that can be reduced, so let's say you have a 4 and a 2, you're going to always reduce those because it's just simply the ratio of one atom to another in the crystal lattice of the ionic compound. However, in this case, a polyatomic ion actually has its own specific subscript. It works like a molecular compound in that it actually indicates just the number of atoms present of each type in that particular molecule. It's a real number of atoms present in the molecule. It's not a ratio is the case for ionic compounds. So we're going to leave them as is. So here's some examples. So you have sodium carbonate. So sodium is a cation, and it's sodium on the periodic table. It has an ionic charge of 1+, and carbonate is a polyatomic ion, and it has a charge of 2-. Okay, so if we go ahead and just do our little crisscross method to determine the chemical formula, what we're going to end up with is Na2CO3. Okay, iron hydroxide, iron 3 hydroxide. So again, iron 3 is a multivalent. So we know that it's going to be a 3+. and an OH minus. We're going to do a little crisscross method. We're going to end up with OH3. So notice how here we actually have the polyatomic ion is going to be kept in parentheses, and that indicates that there are actually 3 of these OHs present in this compound. Okay, if we had written it like this, that actually means that we have 1 iron, 1 oxygen, and 3 hydrogens. Whereas when it's written like this, that indicates that we have 1 iron and 3 hydroxide polyatomic ions, 3 hydroxide molecules. Okay, magnesium sulfate, sorry, that's in French. So magnesium has an ionic charge of 2+, and sulfate has, looks like this, SO4 2-. Okay, so we end up with Mg magnesium 2, sulfate 2. Okay, now here we actually reduce the subscript that's within the ionic compound. So I know it's a little bit confusing because I just said don't reduce the subscript, but what I'm talking about here is you don't reduce this subscript. Okay, you don't like multiply this in and then get an 8 and do all sorts of crazy things. No, you just reduce this subscript like that. So how do we name these compounds? So they're named in the same way as other ionic compounds, but you have to be careful. So a polyatomic ion always keeps its own name. So you don't change the ending. Unlike we do in typical ionic bonds where we change it to "-ide", we're not going to do that. We're going to keep it as is. The polyatomic ion is often found in parentheses. So what that means is, like we've seen a little bit higher up here, so you often have situations like this iron oxide, or iron hydroxide, sorry. So you often have situations like this where you end up with a polyatomic in parentheses. Okay, so that should really be a flag that, oh, I have a polyatomic ion present in this compound. Everything that's found after the metal is part of the polyatomic ion. Okay, so let's do some examples. So example 1, you have AlOH3. So we're going to identify the positive ion, which is the cation, and that's aluminum. The anion is hydroxide. So that becomes aluminum hydroxide. Okay, here we have NH4Cl. So this is the rare case of a polyatomic ion being the cation. So this is ammonium. This is chloride. So we end up with ammonium chloride. Here we have another case of ammonium. And notice how it's in parentheses here. Okay, so we actually have 2 polyatomic ions present in this ionic compound. We have our cation, which is ammonium, and our anion, which is phosphate. So you end up with ammonium phosphate. Okay, and that's it. All right, last words of advice. Be careful not to confuse binary ionic compounds with polyatomic ionic compounds. Okay, so this is just basically reminding you that in the case of binary ionic compounds that we talked about earlier, the ending is going to have an "-ide" ending. Okay, so that means that the second option here, magnesium sulfide, is your binary ionic compound, okay, which is going to look like this. This is binary ionic. Whereas magnesium sulfate, that is actually a polyatomic ion. Well, it's a compound with a polyatomic ion in it, and it has this as its chemical formula. Okay, that's it. As always, if you have any questions, don't hesitate to email me or contact me over Classroom. I'd be happy to help.